So this video is on the fundamental theorem of calculus, where we actually work out by hand what the definite integral is. So we do our integral, but when we do our integral, we put it in the square brackets and we put the a and the b values on the right hand side. And then we sub the b value into the function and minus from that the a value subbed into the function. So we've got a few examples and then you'll see how it works. So for a here, first thing we're going to do is work out the integral and put it in square brackets. So it'll be a half x squared minus 2x and from 0 to 3. Now the next step is we sub in the 3 first into the function. So we'll have a half multiplied by 3 squared minus 2 times 3. And we minus from that the bottom value subbed into the function. So it'll be half times 0 squared minus 2 times 0. And then we work that out. So this will be 9 on 2 minus 6. And then this second part will just equal 0. So it'll be minus 0. Then 9 on 2 minus 6 is minus 3 on 2. These questions also generally come in non-calculator exams when they need you to work it out by hand. So with b the same thing. First thing, do the integral. So 1 on t will become ln t from 2 to 6. So in the values, so it would be ln 6 minus ln 2. So that will equal our log law. So remember, we've got to do ln. When it's a minus, we do first number divided by the second number, which equals ln 3. Now, as I said, these are usually non-calculator questions, which is why I'm going to leave my answer as ln 3. And then the c, we've got 4e to the u. So the integral would be just 4e to the u, because remember, e to the u, the integral is the same, doesn't change. And we're going from 0 to 2. So it'll be 4e to the 2 minus 4e to the 0. 4e to the 2 is just 4e to the 2. Now 4e to the 0 will just be 4 because e to the 0 is 1. So once again, we leave our answer like that because we're not going to use a calculator. D. We're going from negative 2 to 2 of 2x squared times by x minus 3. So with this, realistically, the easiest thing to do would be to multiply out the brackets first. So we'll still have the integral from negative 2 to 2, but then we'll have 2x cubed minus 6x squared dx. Next step, do the integral. So it'll be 2 on 4, x to the power of 4, minus 6 on 3, x to the power of 3, from negative 2 to 2. Then we just sub in the values and we can simplify the fractions too. So obviously that will be a half multiplied by 2 to the power of 4 minus 2 multiplied by 2 to the power of 3 minus, now we sub in the bottom value, so it'll be half minus 2 to the power of 4 and then minus 2 multiplied by minus 2 to the power of 3. Now once again, I want you to do these without a calculator. So here 2 to the power of 4 is 16, half that, which will give us 8. Minus 2 to the power of 3, which is 8 times by 2 is 16. And the second half minus 2 to the power of 4 will also be 16, so that will still be 8. Minus 2 to the power of 3, there will be negative 8 times by 2, which means we'll end up with plus 16. 8 minus 16 is negative 8. 8 plus 16 is minus 24, so we'll end up with minus 32. Once again, these are numbers you would be expected to be able to work with in a non-calculator exam. And then E. So here we've got 2x plus 1 all to the power of 3. So the first thing we need to do is our integral of this. So remember, we've got 1 on a first, which we want on the number in front of the x, multiplied by 1 on, add 1 to the power, the bracket stays the same, add 1 to the power. Then we'll just tidy this up before we do any substituting. So we've got a half times a quarter, which is an eighth, of 2x plus 1 to the power of 4 from negative 1 to 0. Now we sub in. So we're now going to have 1 on 8 multiplied by 2 times by 0 plus 1 all to the power of 4 minus, and then we sub in negative 1. So we just got to work through these logically. So if we look at the brackets first here in this first part, we've got 2 to the power of 2 times 0, which is 0, plus 1, which is 1 to the power of 4. 1 to the power of 4 is just 1, so this first one is just going to end up being 1 on 8. The second one, we've got 2 times minus 1, which is minus 2, plus 1 is minus 1. Minus 1 to the power of 4 will just be 1, so it's going to be 1 on 8, which will give us 0 overall. F, we've got from negative 5 on 4 to 1 of the square root of 4x plus 5 dx. So first thing we want to do is rewrite this without the square root, which would be 4x plus 5 to the power of a half. Now we need to do our integral, which would be 1 on the x value, which is 4, multiplied by 1 on, add 1 to the power, which is 3 on 2, of 4x plus 5 to the power of 3 on 2, from negative 5 on 4 to 1. Now we can make this look a bit nicer. So I've just got up here, so if we have a quarter times 1 on 2/3, which is 1 on 3 on 2, which is the same as 2/3, that equals 2 on 12, which equals 1 on 6. So here we'll have 1 on 6 and then 4x plus 5 to the power of 3 on 2, from negative 5 on 4 to 1. So now we want to sub in our values. So the ones on the top, so that subs it in first. So we'll have 1 on 6 multiplied by 4 times by 1 plus 5 to the power of 3 on 2 minus 1 on 6 multiplied by 4 times negative 5 on 4 plus 5 to the power of 3 on 2. Now working this out, have 1 on 6, we're going to have 9 to the power of 3 on 2 minus here 1 on 6, 4 times negative 5 on 4 is just negative 5 plus 5, which is 0, so that's just going to end up as 0 on this side. So we just have to look at that first bit now. Now, we've got to think about here what we can do with this. 9 to the power of 3 on 2. One thing we could do, I'll step this out in more steps, we could change this as 9 to the power of a half cubed. Now 9 to the power of a half is the same as the square root of 9, which is 3. So we end up with 1 on 6 times 3 cubed, which is 27. So it's 27 on 6, which simplifies down to 9 on 2. And the final one, G, we've got from 1 to 3 of e to the 4x plus e to the 2x divided by e to the 2x dx. First step that we will do with this one is to separate out the fractions. So we'll have e to the 4x on e to the 2x plus e to the 2x on e to the 2x. E to the 4x and e to the 2x, index laws, just minus them from each other. So 4x minus 2x will give 2x, we'll have e to the 2x, and then e to the 2x divided by e to the 2x is just 1. Now we can do the integral of this. So at e to the 2x, we do 1 on 2, e to the 2x, plus x, the integral of 1 is just x, and we're going from 1 to 3, and then we sub our values in. So we'll have half e to the 2 times 3 plus 3 minus a half e to the 2 times 1 plus 1. So then we'll have half e to the 6 plus 3 minus a half e to the 2, and then expand the brackets, so minus 1, which will give us a half e to the 6 minus a half e to the 2 plus 3 minus 1 will give us plus 2. Area between two curves. So the area between two curves can be found using a definite integral from a to b, which are the intersection points of the two functions, and y1 minus y2, so one function minus the other. Now the first function has to be the function that's on top, and you minus the bottom function from it. So we're going to do 3 examples. The first one, we're going to try and attempt to do it without a calculator, because this can sometimes come up. So we'll find the area of the region bounded by the curves y equals 4 minus x squared and y equals x plus 2. So the first thing I will be doing here will be to find the intersection point, so we can find out where the integral is going to and from. So to find the intersection points, we want to find when they are equal. So we want when 4 minus x squared is equal to x plus 2, and you'll notice that it's a quadratic. And if we rearrange it, we'll have x squared plus x minus 2. We can factorise that to be x plus 2 and x minus 1, which means x plus 2 equals 0, x minus 1 or x minus 1 equals 0, so x equals negative 2 or x equals 1. So our intersection points are at negative 2 and 1. So that's the basis of our integral. Now we have to think about which integral would be on top between these 2 points. Now the quadratic part, which is the y equals 4 minus x squared, it's a minus x squared, which means it's a sad face. And then x plus 2, we know will be a straight line. Now if the intersection points are at minus 2 and 1, you can deduct just by using a bit of logic that the 4 minus x squared must be on top because of the type of curve it is, as it is a sad face. So then we can write our definite integral. So the integral from our negative 2 to 1, because there are intersection points, of the function on the top, which is 4 minus x squared, minus the bottom function, which is x plus 2. And from here then, we just work that one out. So personally what I would do here would be just to write this a bit nicer. So we're going to have minus x squared minus x, and we're going to have 4 minus 2, which is plus 2, and then do our integral. So we'll have the integral of negative 1 on 3 x cubed minus 1 on 2 x squared plus 2x from negative 2 to 1. And then we can do our substitutions. So we'll have negative 1/3 multiplied by 1 cubed minus 1/2 multiplied by 1 squared plus 2 times 1 minus, and then the negative 2 substituted. Work this out, so this one part will be negative 1/3 minus 1/2 plus 2 minus negative 2 cubed is negative 8 multiplied by negative 1/3, so that will be 8 on 3. Negative 2 squared is 4, so it'll be minus 4 on 2 minus 4. So here we've got minus 1/3, and then we've got minus 8 on 3, which will be minus 9 on 3, so that will just give us minus 3. We've got this minus 4 on 2 here, obviously will just equal 2, because it's 4 divided by 2. So we'll still have 1/2 there, and then we'll have 2 minus minus 2, which is plus 2, which is 0, and then minus minus 4, which will be plus 4. And then when you work this out, you end up with an area of 9 on 2, or 4.5. Now next one we can use a calculator, so we want to find the area of the region bounded by the curves f of x equals e to the 2x plus 1 and g of x equals x plus 4. So because we have your calculators, graph them in your calculator and you will see what that looks like, and you'll end up with, so this is just a really quick sketch. You'll have one that goes like that line and one that goes like that. So obviously the orange one is the x plus 4 and the purple one is the e to the 2x plus 1. Now on your calculator, you can find the intersection point yourself, so I want you to do that on your own, find those intersection points, and then we can create our integral. So once you find the intersection points, you'll have found that they are. So once you've found those intersection points, you'll find the bottom one is negative 2.997 and the top one is 0.6469. And the top function, here's our shaded area. So the top function is the x plus 4, so it'll be x plus 4 minus e to the 2x plus 1. Now because you've got your calculator, just as you did in an earlier video, put it in your calculator to solve. It's all above the x-axis, so you don't need to worry about the. So just put that into your calculator to solve and you will get 4.83. And then last example, find the area of the region between the curves x cubed minus 3x squared plus 3x and g of x equals x squared. Once again, you're allowed to use your calculator for this, so I want you to have a graph of this and see what you find. So you will find you get a graph that looks something like this, and then when you find your intersection points, you'll see there's actually 3. You've got the origin from 1 to 1 and from 3 to 9. So when this happens, it means we're going to have lots of integrals because we've got the area shaded for the first part and then the second area that's shaded. So our first area is from here to here, and then I'm just shaded in purple. And the top function there is the x cubed minus 3x squared plus 3x, the green line, minus the pink function because that's on the bottom, which is x squared. Now we need to add to that the second area. So the second area goes from 1 to 3. Now the top function of this one is the x squared, and the bottom function is the x cubed minus 3x squared plus 3x. Now once again, as you have your calculators, you can put this in there yourself to work it out. And what you will find is you get 37 on 12, which is approximately 3.083 if it gives you a decimal answer.